Alright, this is the second part of triangle similarity, and what we're going to do is we're going to go through a proof, and then we're going to do a problem where we find a length in a real-life situation. So let's talk about this proof first. This is example 4, so this follows on the heels of us talking about angle-angle triangle similarity, side-side-side triangle similarity, and side-angle-side triangle similarity. Okay, and so we can use any of those three things to prove that these triangles are similar. Let's look at what we've got. First of all, we're going to start out with our givens, and so we're going to put A is the midpoint of BC, okay, and that's given. Now once again, if you're not printing out these notes, that's a good idea because then you'd already have this little box put in there for you. And we're going to put D is the midpoint of BE, also given. Okay, now let's look at what this means for us. If we know that A is the midpoint, then we know this. And I'm going to mark it. Right? And if we know D is the midpoint, we know this. How can we use that? Let's think for a minute. Right now we're talking about a side here, side BC, and we're also talking about side BE. Well, if we have two sides, we either need to use side, side, side triangle similarity, or we can use side, angle, side. Let's think about the previous examples that we've used. When we had two triangles inside of one another, this little guy up here and then the whole thing, BCE, they share an angle. They share angle B. And so realistically, I've got side, angle, side triangle similarity. So what we need to prove is, first of all, that the sides are proportional. And second of all, that this angle B is congruent to angle B. Well, we know that's going to be reflexive property. Let's talk about the sides first. If we start to talk about the sides, we can say that BA is congruent to AC. Because if A is the midpoint, then that means that it divides it directly in half. Also, we know that BD is congruent to DE. The reason for each of those is the definition of midpoint. Look at what that gives us. If we start to talk about AB, this segment here, and it's half of BC, we know the ratio of those sides is going to be either 1 piece over 2, because there's 2 of them, or 2 over 1. And so the ratio of the other side must be the same because it's divided in half also. And so let's look. If we need to talk about things being equal, we need to say the next step is that these segments are equal. Because what we are going to end up doing is we are going to end up saying that the big segment is 2 times the little segment. So I'm going to convert these into equals so we can talk about that easier and substitute them. So really that's just the definition of congruence. Okay? Because the definition of congruence is saying really the side lengths are equal, right? Okay, so now let's talk about the sides as being proportional. Okay? We've already said something about the small sides, like AC and BA. But let's talk about the side as a whole. We know that BC is equal to BA plus AC. We also know that BE is equal to BD plus DE. We need to talk about the whole side, because if we're going to compare the little part to the big part, we need to know, what does the big part actually equal? Well, we know that it's 2 times one of the little parts, but we need to actually have a statement that says, hey, it's 2 times the little part. And so really the reason for this is the segment addition postulate. Right? Because all we've said is that a big segment is made up of the 2 pieces that it's made up of. Okay, and so now let's think for a second. If we're going to talk about the big piece in comparison to the little pieces, let's do a little bit of substitution here. we know now that BC is equal to 2 times, let's do it stepwise, BA plus BA, because AC is equal to BA, right? So if we substitute it in, and we also know that BE is equal to BD plus BD. And we can do that because that's just substitution. Okay, because up here we said BA is equal to AC, so instead of AC I just put in BA. Now, let's simplify this a little bit. BC is equal to 2 times BA, and BE is equal to 2 times BD. That's just simplification. Why have we done all this? We want to be able to create a ratio because proportionality, similarity, all have to do with the ratio of the sides. Okay, and so now what I can do is I can talk about the ratio of the sides because I can now say that BC over BA is equal to 2 because BC is 2BA. Well, if I substitute in BC, that's one little piece. BA is 2 of those little pieces. That ratio is equal to 2. On the same note, little pause in the action here. On the same note, we can also talk about the other side that we're trying to prove something about. And we can say BE over BD is also equal to 2. Because think about this. The side is twice this little piece. So this side over the small piece is 2 over 1. And so that really is just the division property of equality. Because we know that one of them is 2 of the other one. So 2 over 1 would be 2, right? Okay, so now we have the ratio of these sides, okay? And so let's see. We can say that BC over BA is equal to BE over BD. How? Because we simply use the transitive property. Because if each of them is equal to the same thing, then they're equal to each other. So now we have created a proportion here, right? Because this means that the sides are proportional. That's good, because now that the sides are proportional, we have that piece. And what I need, so now these two sides are proportional. All I need now is the angle in between. So I'm going to say that angle B is congruent to angle B. And that's just reflexive property. Actually, it's of congruence, right? Because I'm talking about congruence. And so now what I've said is a side, an angle, and a side have the relationship that the side is proportional to the side, the angle is congruent, and the side is proportional to the side. So now I can say that triangle ABDA is similar to, let's rewrite this, I'm sloppy. Triangle BDA is similar to triangle BEC because of the side, angle, side, similarity theorem. Okay? Systematically proving each of these things. Okay? Make sure you write down questions in the margin if you have those, because we can talk about those in class. Okay? Let's go down and solve an actual problem. Engineering application. The photo shows the gable of a roof, which is the front part of that roof that shows it sometimes has a window in it. And it says that AC, this part down here, is parallel to FG. Use similar triangles to prove that the two triangles, the little one and this big one, are similar. Then find the length. This is good for us because we're actually saying, we're applying this. Okay? Let's think about this for a minute. they wouldn't give you the fact that these are parallel for no reason. And so let's think for a minute. To prove that these triangles are similar, well, because they're stacked on top of each other, we're already going to talk about this angle here. So angle B is congruent to angle B. You can pretty much always say that because that's reflexive property. Right? So that's always going to be true. We're going to use that like 9 times out of 10. But the other thing that we need to talk about is this right here. So I've got this angle here, and that's not a good color to use. Let's use blue. Okay, I've got this angle here and this angle here. Well, I can say that angle BFG is congruent to angle BAC because, look at this. If I have two parallel lines that are cut by a transversal, these are corresponding angles. Okay, so those are congruent. And if you remember, we're talking about triangles being similar because of two angles. So triangle ABC is similar to triangle FBG by the angle similarity postulate. Theorem. So now I've proven that these two triangles are similar. And so what that means is all of the angles are congruent and the sides are proportional. Well, notice what I've got here, guys. I have this bottom side, and this goes with this right here, and this 24 goes with the bottom. So the bottoms are proportional. So I can say that 6.5 over 24, having trouble with the 4s today, they're all running together. So 6.5 over 24 is equal to anything that I want for the other sides. And so if I want to find BF, I want to find this part here, right? Well, that's part of the little triangle. So that's going to be BF over. Now, this side is proportional to this whole side here, right? If this part is 17, and I don't know BF, I can say that this is x plus 17. Well, this part up here is the part that I don't know. And so now I've got something that's sort of equal. It's good. Okay, and so I've set up this proportion to say that I have part of a triangle, this little part, over this whole side is equal to the small side over the big side. And so when I actually multiply this out, I've got 6.5 times x plus 17 is equal to 24 BF. Okay? Let's distribute this out. 6.5x plus 110.5 is 24 BF. Let's take it up here. If I subtract 6.5x from both sides, I know that BF is actually equal to x, right? And so I've got 6.5x plus 110.5 is equal to 24x. I'll subtract 6.5x from both sides. Alright, I'm combining like terms. Gone. 110.5 is equal to 17.5x. Divide by 17.5. I end up with 6.3 about, because I'm rounding to the nearest tenth of a foot, is equal to x. So BF is 6.3. Okay? Use the proportional sides. Because once you prove that those triangles are proportional, you can prove something about the sides. You can prove what the lengths are because the ratios have to be the same. So the ratio of BF over the whole thing has to be the same as the little part of BF over the whole thing. Okay? That's how this works. Let's do a little bit of a review. The properties of similarity. Reflexive property of similarity. Things are similar to themselves. Okay? So the size of something is similar to itself. The ratio would just be 1 because it's the same thing over the same thing. The symmetric property of similarity says if ABC is similar to DEF, then DEF is similar to ABC. They'll just be inverse ratios, right? Transitive property. If something is similar to something else, and that DEF is similar to yet another thing, then we can cut out the middleman, okay? And so these properties of similarity are going to allow us to solve for sides, solve for angles, and find the lengths that we're missing. Alright guys, thank you for watching. I know you're going to have questions about these, but we're going to continue to go through and solve for different lengths. So keep on watching, keep taking those notes, and we'll see you next time.